Okay, before we start this lesson, there is a graphic organizer with the vocabulary that you're going to need. So make sure that you request that from the teacher. Go ahead and hit pause and get that from the teacher. These are the vocabulary words that you need to have for this lesson, and you need to also make sure that you have symbols, if I have any for you, and picture or an example that I do, and this is going to be a great way to organize your notes. Things to look out for right now. We got adjacent angles, vertical angles, complementary, supplementary, perpendicular, and angle bisector. And we've already talked about angle bisector in the last video, but we'll talk about it a little bit more on this one. Okay, so if you remember from the last video, we had what was called a straight angle. And I said if you were to measure the straight angle with a protractor, how much did it equal? Well, it was half a circle, so its measure was 180 degrees. Well, if you have two angles, PRS and SRQ, that are adjacent to each other, that means they share a common ray and vertex. They are adjacent to each other, and they lie on a straight line, then their sum is 180 degrees. So these two angles together are 180 degrees. So if I have PRS, which is 20, that's not 20, let's say 120 because it's obviously obtuse. Say it's 120. Well, the two of them together are aligned on a straight line. So they are supplementary, which is 180 degrees. So then this would be 60. 60 and 120 is 180. So the linear pair conjecture, and that's something you want to have, if two angles form a linear pair, then they are supplementary, or they have a sum of 180 degrees. Okay, and one of the ways that I remember supplementary versus complementary, supplementary, if you spell it out, S-U-P-P-L-E-M-E-N-T-R-Y, you can turn that S into an 8. So it kind of triggers your brain to think 180 degrees, right? Because so many times students confuse complementary with supplementary, and they always get them mixed up. So any way that you can think of to memorize that supplementary is your 180 degrees, whereas complementary is your 90 degrees, that's going to help you out a lot. If you don't have this conjecture memorized, and you don't have the word supplementary memorized, you're not going to be able to be successful in this class, at least. All right, so let's look at an example. As you can see, that angle LON and angle LOM, if we pulled them apart, they would not exist without LO. So they share a common ray and vertex. So these two are adjacent angles, and they lie on a straight line. So they have a sum of 180 degrees. So what I just said verbally, we're going to write out algebraically. You have angle NOL plus angle LOM with a sum of 180 degrees. So that's how we do it. 2x plus 24 is NOL, and LOM is 4x plus 36 equals 180 degrees. We're going to add our like terms together. 2x and 4x is 6x, and 24 and 36 is 60, and that equals 180 degrees. Subtract 60 from both sides. 6x equals 120. Divide by 6. X equals 60. So always check to make sure that that does in fact equals 180 degrees. So plug your x back in. 2 times 60 plus 24 plus 4 times 60 plus 36. I'm just going to plug and chug that into my calculator. Give me 1 second. Okay, and it was a good thing that I plugged that into my calculator because that is wrong. I did some horrible math there. 120 divided by 6 is 20. So this all changes to 20. And now I'm going to double check in my calculator to make sure I did this correctly. And I got 180 degrees. All right, so now that you know about a linear pair, let's go ahead and try this example here. Go ahead and pause your video, and I'll give you the answer in just a minute. Okay, so the way you set it up is 75 plus 2x minus 5. You add these together, set them equal to 180. That's going to give you x is 55. Here's the algebra worked out for you. Raise your hand if you have a question. And I went in and checked it just to make sure that it did in fact equal 180, and it did. Alright, vertical angles. Vertical angles, you need to have the definition of just vertical angles. Vertical angles are angles that are non-adjacent. They share a common vertex. And they are across from each other. So, we have angle 1 and angle 3 share this vertex right here, and they are across from each other, and also they're formed by two lines. Okay? So, you also have vertical angles. Oops, where am I going? You also have vertical angles at 2 and 4. Okay, they are across from each other. Boom, boom. They share a common vertex. They are not adjacent. And another way you can pick out what a vertical angle is the two angles make a V and an A for vertical angles. So vertical angles. See how they look like a V and an A? That's how we remember that they're vertical. Anyway, the nice thing about vertical angles is that they are going to be congruent. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And I just go up an arc every time that I am identifying angles as congruent. So I already used one arc to identify 1 and 3 are congruent. Now I have to use 2 arcs to identify 2 and 4 are congruent. Okay, so if two angles are vertical angles, then they are congruent. Okay, and I also cleaned up the definition over here of vertical angles so that you can add that to your notes as well. We got vertical angles are formed by 1, 2 lines. They're not adjacent. Angle 1 does not share a common ray with angle 3. And they do share a common vertex, that's right here, and they're directly across from each other. Okay, so we're going to take the definition of vertical angles and the fact that they are congruent and apply that into a scenario. So we're going to solve for x on this example. Oops. So like I said, vertical angles are congruent. So we're going to take that and put it into algebra to solve for x. We're going to put an equal sign in between the two angles. So 4x, whoops, that's ugly, 4x plus 50 equals its vertical angle 2x plus 60. Okay, so we can subtract 50 from both sides. So we get 4x equals 2x plus 10. We can subtract 2x from both sides. So we get 2x equals 10. So x is 5. Okay, I'm just going to go back and check to make sure that they're equal. I'm going to plug my x is 5 into the first angle and ask myself, does that equal 2 times 5 plus 60? 4 times 5 is 20 plus 50 is 70. So 2 times 5 is 10 plus 60 is 70. So I did that correctly. Go me, yay! Alright, now why don't you go ahead and pause the video. Same concept applies. Vertical angles are congruent. And we're going to do the same thing. We're going to solve for x. You try it. Okay, so here's how I set it up. Vertical angles are congruent. So I set 2x plus 40 equal to 110. You could have done 110 equals 2x plus 40. It doesn't matter. Remember, that's your symmetric property right there. You can flip it. Okay, so I solved for x. I got 35. I plugged it back in. It did equal 110. So I am good to go. Hopefully you are too. Okay, the next thing we're going to talk about is perpendicular lines. Perpendicular lines are two lines, and if I can extend this, two lines that meet at a 90-degree angle. And because they meet at a 90-degree angle, their vertical angle will be congruent. So this angle would also be 90. And because they sit on a line, their adjacent angles would be 180 minus 90, which is 90. So this angle right here would also be 90. So anytime you got perpendicular lines, everything around here is going to be 90 degrees. Okay, so I wrote the definition right here real nice for you, so you can take a second to write that down. The symbol for perpendicular, if I say, let's name this ABC. Okay, let's say that ray BA is perpendicular to ray BC. I can, instead of writing the whole word perpendicular, I can write an upside down T. And if you notice, an upside down T even looks like it has a 90-degree angle there. So if I tell you that BA is perpendicular to BC, you would automatically put a right angle there. Perpendicular means it intersects at a 90-degree angle. So these two rays can also be perpendicular, but these two rays are perpendicular and they form a 90-degree angle. So make sure you have this symbol, because you're going to see this symbol more than you're going to see the word perpendicular. So we'll have that right there. So now let's see this in an example. Okay, this angle has been designated as a 90-degree angle. So what did we say about that? Well, if you notice, these three angles, 1, 2, 3, are all sitting on a straight line. So I'm going to kind of draw it like this. So we got our 40 here, and we have our 6x plus 2 here. They're sitting on a straight line. So the linear pair theorem says that angles that lie on a straight line are going to be supplementary. So all three of these are 180 degrees. But what did I say about perpendicular? Well, I said if you have two lines that meet at a right angle, then all of these angles are also right. So we don't have to set all three of these equal to 180. We can just set these two angles here and here equal to 90, because these set of adjacent angles, that 40 and that 6x plus 2, they are going to equal 90 degrees. So let's do the math here. 40 and 2, like terms, 42, plus 6x equals 90. We're going to subtract 42 from both sides. So we're going to get 6x equals 48. I'm going to divide by 6 on both sides. So I get x equals 8. And I'm just going to double check to make sure that when I plug x back in right here, so 40 plus 6 times 8 plus 2 should equal 90. So 40 plus 48 plus 2, 48 plus 2 is 50, plus 40 is 90. So I'm good to go. Alright, so for this next example, this is that symbol I was telling you about, that upside down T. That is telling you that AB is perpendicular to AC. So we're going to solve for x. Go ahead and I'm going to write that down for you. Solve for x. Pause the video and see what you come up with. Okay, so I set it up, the two angles together, they're 90 degrees. 6x equals 90, x equals 15. I'm going to go back and check. 2 times 15 is 30, 4 times 15 is 60, and 60 plus 30 does in fact equal 90. Okay, so let's look back at your vocabulary chart. That's the end of the notes for now. If you want to go ahead and move on to the worksheet, now would be a good time. But I want to go back to these definitions and stuff. The adjacent angles are going to be two angles that share a common ray and vertex. They're right next to each other. Okay, and we don't really have any symbols for that. It's just that you just have to know that when they share that common ray, if you were to take away that ray, you'd only have one angle. That's how you know you have adjacent angles. Okay, vertical angles, remember those are your angles that are formed by two straight lines. and they're right across from each other. They form a V and an A. If you want to write that off to the side, VA for vertical angles. They are not adjacent. They don't have one common ray. This ray here isn't common with this ray here, isn't common with this ray here, isn't common with this ray, and they're congruent. All right, complementary angles. Remember I said complementary and supplementary, we always get those confused. Complementary angles are angles whose sum is 90 degrees. It's going to be more than one angle. And the way I remember complementary is the letter C, if you draw a straight line down, it forms the number 9. So 9, 0 for 90 degrees. Okay, and then we have supplementary. If you remember for supplementary, I took that S and I drew an 8. So it reminded me that I had 180 degrees. So supplementary angles are going to have a sum of 180 degrees. And then we had perpendicular symbols. We got the upside down T for perpendicular. And those are going to be two lines or two rays or two segments that meet at a 90 degree angle, or that form a 90 degree angle at their intersection. And then finally we have our angle bisector, and I just wanted to have this on the same page. I know we did angle bisector last time, but your angle bisector is going to be a ray that bisects an angle or splits it into two congruent parts. Okay, so that does it for this lesson. I hope you get a great grade on your exit quiz and that you are finding this to be a little bit easier, and good luck.